presentation and also the terminal?
Yes, both of them.
Okay, yes, great. So we will cover the topic remotes with Git, yes, in this lecture. And here is a definition from this book from Scott Chacon and Ben Strapian. And it says a remote repository is a version of the project which can be hosted in your local machine, some network over the internet, where you and your collaborators can put some modifications, which is called a push and pull in the Git terminology. So basically, the remote is another repository that is not the current one where you are working. This is essentially a remote, and when it is connected somehow to your current repository, then it's basically what is a remote, right? So this is a very simplistic workflow, yes, so where you have some collaborators and you want to share the code you are working on, yes. So one way to do that is to place the entire code and the history of the changes in some public repository, yes, and then all the collaborators can get the code from that repository, and then they can modify the code here and make changes, and the others can get the code and the history of that. So one thing from Git is that all the collaborators can get the entire history of the code, right? So that's a very nice point that older version control systems didn't allow it, or it was too complicated to do that. But with Git, you can get the entire code, the entire history, and if some of the repositories, for instance, this local or this local repository are broken at some point, or the laptops are destroyed, then you will be able to get the entire history from the rest of all the collaborators or the center repository. So it's a good idea. Yes, in case your local PC or laptop breaks. And here there is again the picture that I showed at the beginning of my previous talk. And I mentioned that at that point, right, we would be working in the local repository. Yes. So what we have done up to now with the Git init, setting a repository and committing, adding, right, was at this level, right? So this is called the local repository. And now we will see how to work with a repository that is not the local one, the current one, and this is the remote. So here you can see the influence or the effects of some commands that you may have seen. For instance, if you clone the repository for the Git course, you most likely use this git clone, right? And you can see here the effect and the influence, yes, of these commands. And we will cover other commands like these three here. So this is basically what the remote is, right? Something that is not your local repository.
Pedro,
Yes,
one silly question. What is a Git bucket? Does it matter? Just it was in your first slide.
I see.
Was
Yes. I put it on purpose because most people I know talk about GitHub, right? But Bitbucket, it's another a public repository where you can push your code, you can upload your code, and you can work in the same way as a GitHub, right? Or GitLab. GitLab is also a public repository. But
Okay,
public,
so
yes.
Bitbucket is like a kind of GitHub, but another provider, let's say.
Yes, yes, that's
Okay.
correct. Yes. Also, you can try GitLab. It's a similar. They have the different policies, yes, and one should explore them. But essentially, you can place your code and work on them, similar to GitHub. So, some basic commands to know more about your repository or the remote is the repository. You can type a git remote dash v. Interesting, I see a line. Okay, on my terminal. And in this command, git remote dash v will give you the information about the remotes that are available for your repository. So if you clone this repository from either Bitbucket, GitLab, or GitHub, then these public repositories will set an origin, yes, by default, right? So for instance, for this particular repository, I clone the Git course from this URL, yes, that is available on Bitbucket, yeah. And you can see here that it established or put the default origin as this URL. And it says you can fetch and push from this URL. So this is similar as to GitHub. For instance, in one course or one project that I cloned previously, you can see that if I type git remote dash v, then it will tells me the URL from the origin where I cloned this repository. So here you can see the information of the repository. And if you type a git graph, if you did this uh, shortcut that I showed you before, and it was also discussed previously to display the commits in a one-line manner, right? You will see that besides the main and the head, right? The main branch and the head that is pointing to the main branch, you will see that there are other branches, for instance, this origin, main and origin head that are available in the repository. So if you set your Git repository manually with Git init, for instance, and you haven't added any remote, then you shouldn't see these two. So the point here it was to show you that if you set or if you clone a repository, then you will get an extra line here or sentences here saying about the origin, which is referred to the remote. So I thinking if I should delete this line that is, let me see. I don't know if I did it by mistake. Clear all drawings. Okay, no, because it can be disturbing. Yeah. So then there is a command in Git to add a remote. Yes. And this can be useful if you first set up a project manually, as I mentioned before. Imagine that you have your initial code, like the one I created previously, my first repo. And here I have some files, right? And I started working on this. But if I check git remote dash v, then you will see that nothing is there because I set this repository manually. So in this case, right, adding a remote is useful because you can create a repository in some a public platform like GitHub, Bitbucket, GitLab, and then you can add the remote, yes, the URL that you get when you create a repository, and then you can connect your brand new repository to the one that you create on GitHub. Then I add this remote repository to this manually created repository, and I can export or I can push in Git terminology the branches and everything to this remote repository. Yeah. So this is one way to work. This is a simple case. Another case can be, for instance, if this is an existing repository where people have been working, they have already some branches, many commits, and so on. And then if you add the remote to the brand new repository, then you can fetch everything from here. You can get everything, all the branches, all the commits to your local repository. However, I need to clarify at this point that if this is already an existing project, it has some history, right? It has branches, commits, and files, everything. So this adding of the remote step, yeah, should be done in a completely empty repository. So otherwise, you will get a load of conflicts, right? So, so these are the protocols that can be used for connecting the remotes. One of them is the local. For instance, if in a machine, any machine like this one, Kebnekaise, I create a repository, and then other people can go get the path, yes, the path to this project, and then they can use the command clone to get a copy, yes. Another one, these two, these are the ones that I mentioned. Here, GitHub, you can see the SSH and HTTPL, HTTP or HTTPS, yes, they are supported protocols for Git. And this is a trickier one, and it's not very common. It's called the Git protocol, right? So this is uncommon to find this one. So why do we need more than one remote? And here there is a simplistic picture, and I will extend this picture later on. So imagine that you found on the internet, for instance, some repository. Yes, you get a copy of it from this user, Bob. So you're the user Alice at this point. So if you get a copy of this repository, through GitHub, for instance, or GitLab, then this is called the fork. And I will explain you later on what is this forking process. So once you get this on your GitHub account, then you can use the URL of this repository, and then you can clone that with the git clone command. Yes. And then you will get the local copy, which will be, for instance, on your laptop or your PC. And because you can connect here to these two places, to the fork copy through the SSH keys, for instance, then you can put changes, get changes, and so on, only from this one. Because in this case, maybe you don't know personally, or you don't know this person here, and you are not allowed to modify directly the repository of this person. You can only modify the copy that you have on GitHub. So, and that's why it's useful to set more than one remote. In this case, if you get the repository from your fork repository, then this will serve, for instance, as an origin because it is set by default by GitHub when you clone the repository. And in addition to this, you can add the repository of Bob, and you can call it upstream or anything you want. And in that case, you will still get the changes from Bob, yes, in case Bob decides to update his repository. Or even imagine that you continue working on Bob's repository, you discover some new feature, you implement that in the code, and then you can ask Bob, do you want these changes that can enhance your code? And then there is a way that we will see later on how to make Bob aware of your changes. That's why we need more than one remote. And actually, this is a very simplistic picture because you can see that there could be many more collaborators, and all of them could have their own repository for some project, right? There are some codes that are big and yes, and many people around the world are developing them. And that's why it's useful to have a upstream or another remote so that you are aware of the changes that are being done on different parts of the world. So but this is a case of two users only. So, okay, so here we add the upstream repository. You can name it as you wish. And in that case, we are adding this URL, this project that is on GitHub. And if you type now a year remote, you will see that the initial repository that was cloned was this one from the user Alice. And then the upstream repository was from this user Bob, right? So you have now two repositories. And as I said before, because this is the user, yes, that clone the repository from her account. Here, she should be able to put changes once she sets the SSH keys, for instance, but here not. So the user cannot put changes on this repository because she has not access to it unless Bob gives her the access to write on this repository. That's the point. Yeah. Yeah, once you add another remote, then if you type the git graph, this shortcut, that we mentioned previously, then you will see that besides the main head, the main the main repository, or the main branch, sorry, and the head, you will see that the upstream main is also there, and also the origin and the origin head that were previously before you added the upstream remote. And you can see that now at this point, all of them are synchronized, right? Because most likely this was the point where you clone the repository, and you also set immediately the upstream. But if, for instance, you keep working on the repository, then this will be asynchronous with the others, and also the upstream can be asynchronous with the other two remotes. So, okay, so how to get the changes from the remotes, and how to put some changes on the remote. So Git offers these commands: git push, the remote name and the branch name, to put some changes on the branch called branch name, and also to fetch or to get the changes from one branch to the remote, to the corresponding remote branch. And also the pull command. This is another command that can be used to get the changes. And although they have names that sound similar in meaning, they are different, right? I will explain this. So in case you obtain the repository by cloning, yes, if you type git clone, so then this will set an origin by default, which is the URL where you clone that. So that's why when you type git remote -v, you will see automatically the origin that was set when you clone that from GitHub, for instance. Then you can push, fetch, and pull to from to or from this remote with the commands that I mentioned previously. And because there is an origin by default, then you can type the origin, which is the remote, to the master, yes, or the main branch. Use an example. Or there is a shortcut that it's worry to understand. If you type git push without any arguments, git fetch without any arguments, git pull without any arguments, then in this case, the remote will be the origin, which is the default one, and the master branch will also be taken as a default for pushing and pulling by default if you clone your repository. So here, starting to make the changes of the repository. So you can type the command git pull, and this will bring the changes from the branches, right, that are in the remote, and tries to merge them with the current branch. Yes. So notice here the difference. It will bring all the branches or the changes, right? But it will try to merge only the branch in the remote with the corresponding branch in your current local repository. Yeah, you see the difference. Although it will bring all the changes, the merging process will be done only on the current branch. And the behavior for this command, for the fetch part, yes, is given in the git folder and the configure file. So if you clone the repository, you will see some line like this one. So, but if you set that manually, of course, you won't see anything in this related to the remote, right? So it's telling you that the remotes, branches, everything will be fetch, right? Upon pulling. But notice here, there is a fetch part only.
Pedro,
Yes,
I'm sorry. I got confused. What's the difference again between the slide 13 and the 14, in which you have like git push origin master, and you just put like a git push? Sorry, I got confused.
sorry, line 13 or a slide
These, the 13 and the 14.
13. Okay, yes, because in this case, you're specifying what exactly you want to do. So if you do git push, it means you will push the current branch to the origin master. Yeah. In this case, you will fetch the origin remote and the master branch, and so on. So this can be as a shortcut, right? Because these are the two defaults. And I was saying that a git pull command brings all the changes on the branches in plural, but it tries to merge the changes only to the corresponding current branch, right? And this default behavior can be seen here, where it says fetch, and this gives you the behavior. So it means brings all the changes from the remotes and try to fetch them into the local repository. So, but this git pull, and I said that it has two parts. One of them is called fetch, and fetch will bring only the information on the changes on the local, on the remote branches. And this is the picture, where the picture can help us, right? And because it's connected. So here you can see how it's working. So you have the remote, you have added the remote, or well, you have already the remote because maybe you clone the repository, right? So if you type git fetch, so it will put the changes into this folder here, the local copy of the remote branches. Yeah. So notice that at this point, if you do git fetch, then you will not see any changes in your working directory. So it's only a copy, and it is in addition to the commit tree or the local branches folder. Yeah? So there are different. So they are at this point when you do git fetch, we'll get the copies into some local copy of the remote branches. And well, the git pull will do another thing, as you can see here. Git pull will get the changes in the branches and will go up to this stage here in the staging area, or the commit the staging or the index, yes, and it will put the changes up to this point, right? And in addition to getting the changes from the remote, so Git will try to execute another command. Let me see here, which is merge, right? And in the case of the merge, the behavior will be to merge the changes in the branch to the corresponding or the current branch in your local repository. So git pull is a combination of these two things, right? So if you want to work fast, I would say, and you can execute git pull, but a more careful and more recommended way to work is first to get the changes, right, with git fetch, and this will only bring the changes. You're not putting anything in your local or in your working folder. Yes, you're putting them here. Then you can do something that we have used at this point, which is git diff. Yes, and with git diff, for instance, you can see the difference between the files in this local copy of the remote branches and the working directory, and see how similar they are, for instance, and see if the features that you are getting are the ones that you want, for instance. And after you check the changes, then you can execute manually the second command that is merge. Yeah. And with merge, if everything is fine, then you shouldn't have any conflict. But in general, you will get conflicts when you try to merge. If you execute git pull, then it will try these two things. And if the merging process is straightforward, then it will try to do some merging process in a fast forward manner. And otherwise, you will need to solve the conflict. Another way to work with this pull, and I will see if I have time to mention that. But yes, the concept here is that this is composed of two commands, right? This is a recommended way to work. First fetching and then merging. Yeah. And we saw previously that the default remote is the origin, and the branch is the default is the current one. Yeah. That's why if we do fetch, git fetch, then it will try to get the changes on all branches, but the merging will be only on the current one. Yeah. Be careful about this step. Yeah. Okay, so next, the next command. So we have seen how to get the changes that are done on the remote repository, for instance, on GitHub. But if we want to put the changes on the repository on GitHub, for instance, then we can type git push. And this will send the changes in the current branch to the remote corresponding branch by default. Yes, without any arguments here. Yeah. Git push. So this is the default behavior that you will get in general, right? And without any arguments, but we have seen that we can put additional arguments like the name of the remote or the name of the branch. Yeah. Okay, so then this will send the changes in the current branch to the corresponding branch in the remote by default, right? So this behavior can be altered, and I type here more advanced because in general, this is what you are targeting, just the current branch. Yeah? But there are some cases, there could be some cases, and you don't have to change that, right? So if you don't think it is fine in your workflow, you can see the default behavior if you type this command here, and this can be changed. For instance, matching, yeah. which was the default, but now it's simple, which means just the current branch to the other branches. And if you put matching instead, it will take the corresponding branches, right? And then to match all of them with the remote branches. So here is one way to alter the behavior, but it strongly depends on to you. In my case, I have not changed the behavior, but it can be changed. You should change that with care, I would say. So in case you have a brand new branch, in this case, I will call it new. I created a branch and I work on this branch. So that then if you try to push this branch to the remote, remember that we type git push, the name of the remote, in this case origin, and the name of the branch. Then it will git will complain and it will say that the branch is not tracked. So that's why for the first time we need to add this option, yes, to start tracking the branch on the remote as well. And then this command is an entire equivalent to pushing the origin branch new and then setting the upstream on the origin. Right? So you can type this command to start tracking your new branch. So then you will be able to put the changes on the branch by typing git push and pull as we mentioned previously. So this is an information that can be displayed for your repository. You can type git remote show the name of the origin remote. Yeah, and here you can see more information on the branches, right? Which branches are tracked. In this particular case, these branches were tracked and also the information for the pulling command and also pushing. So what can be done between these branches. So this is displayed with the git remote show at the name of the remote. This can be useful in particular, for instance, if you have several remotes. So renaming a remote, if you don't want the remote to be called in some name, you can use the git remote rename, initial name, and new name. So this is how to rename remotes, how to delete the remotes, right? If you don't want them any longer. And here there is also more specific topic related to bare repositories. So in the case of the bare repositories, you don't have a working directory. Yes? And you may think, why do I need this type of repositories at all, right? So, but they are useful in case, for instance, you want to set a central repository where no one is working, but that can be shared and contains the entire history and can serve as a central repository for your code development, for instance. This is a bare repository, something without the working directory. So how to set this bare repository? Follow this command and then instead of using the git init command, then you can use git init dash bare. This will set a bare repository and you can clone the bare repository with the dash bare and the location, the path or the URL of the bare repository. That's also it could also be useful, for instance, if you have a large or a big or a heavy repository in size, yeah, And without the working directory, this reduces the size of the repository so that the collaborators can get it in a fast manner. So we have seen how to set the account of GitHub, and I hope you have done it up to this point, right? Now here is how to create a repository, and if you go to your account, you will see this green button where you can create a repository. So here is how I see when I try to do this. You need to choose a name of the repository. Yeah. In this case, I choose my first repo. You can choose if it is public or private, also a description, right? And you can add README and git ignore files if you need them. Yeah. So I didn't use the option for adding the README and git ignore. Yes, yes, a question.
What is a git ignore? Sorry.
Yeah, a git ignore file is a file that contains uh, the information about the files that Git won't include upon pushing and pulling, right? So as the name suggests, Git will ignore these files. So, for instance, imagine that here during my coding process, I created or my code create the .ex file, which is a binary, or .out or .beam and so on. Yeah. So I don't want these files to be included in the repository when I push the changes in the branch, for instance. So to avoid this, I can create a file in my repository called, for instance, git ignore. And then here I can specify that I don't want the .beam, I don't want the .out, I don't want the .exe file, for instance. And then I need to commit this file. Right? And I mentioned during my lecture on the first day that this is one way to ignore the files, but this can also create some problem because all your colleagues will have the same git ignore file. Yeah? Once you commit this and you push the file, then all your colleagues will have it. But this is a problem because maybe one of your colleagues needs this output. I'm guessing. Maybe he needs or she needs this output here. And because you are ignoring this, that person will also ignore that when pushing and pulling. So that's why I suggested an additional method, right, to this git ignore. But this is essentially what the git ignore file does.
When you, in your example in the Vim, you put like dot whatever name there. Is that the name of the file or is the extension of the file?
You can use the wildcards as I'm using here. This star means anything and it ends with the dot out. So you can also do something like this file and then out and something like that. This is a wildcard.
Thanks.
Yeah. And yes, I didn't choose the README and git ignore options. So my repository will be empty. And that's why I get these options here that how to proceed or what are the next steps that I could take. And it says I can create a new repository on the command line in my local machine. And I need to follow these steps as they appear. Yeah. So now Git change these settings in the sense that now it's called main and not master. So as you can see here, for later versions of Git, the main is recommended. So you can see here that main is used instead of master. Yeah. So you can do set a new repository, then add manually the remote, and this is where a remote add is used because here you are setting your local repository, adding the remote, and then pushing the origin master, right? So notice here that the repository was empty, and that's why I could do it in an easier manner. You can also push an existing repository from the command line. In this case, if you have work on your repository, you have many branches, many files, and so on, then just add the origin as a URL that you created, yes, and then rename or name the master branch as master or main in the latest version, and then you push the branch master. Yeah. Another way that is not covered here is to import from another repository. So in case you have already your repository in some other platform like Mercurial, Subversion, or anything else, then you can import the code directly with the URL. So this was covered by Birgitte, setting SS keys, right? And this was a window to add the SH keys. So once you get the GitHub account, you will see that there are several options. And I like this one. If you go to Insights and then Network, you can see or track in a visual manner the changes that are being done to your repository. Yeah, and especially the commits and branches and the people that are working there, you can see that in a graphical manner. Yeah,
Can you explain how to read this graph? Like, is the past on the left and the future like on the right? What are the dots?
yeah, the dots are the points where you made some commits, right? And because in this case, there is only a single user, which is myself, then you can see here a single name. Yeah. So then, if you have several branches, you will see different colors, right? If you have several users, you will also see them, and you will see when they committed and on what branch, what is the name of the branch, and so on. Yeah, it can get complex, especially when you're working with several colleagues and the project is big. Yeah? And this can help you to see. If you click on one of these points, you will see the commit when it was done. Maybe I can do this. Let me see if I have this here. Insights. Insights and see. Then network. So it takes some time to render, yeah, because depending on the work that you have done, that it could be a large graph. Yeah. So you can see here the name of the branches. I have two branches, and here are the commits, yes, and the commit messages, and here are the users. You can see how it's synchronized and how is the workflow. Yeah. So yes, let me go to this scenario, and that's what I mentioned before. Imagine that you found some repository from Bob. You clone that, yes, with the git clone command. The problem is that now you cannot put the changes on this repository because most likely you don't have permissions to do that. So you can not commit, you cannot push the changes to this repository, right? So what is a better approach, right? So here you found the repository from Bob, then you fork the repository from Bob, right? And you get this in your GitHub account, and this will be the origin that is set by GitHub by default. In this case, you can clone the repository into your PC or laptop, for instance, and because you have established the SH authentication, then you can put the changes here. You can commit, you can push, you can do everything. And here you can still not commit to Bob. Yeah? But then you can add Bob as an upstream, for instance, and you can make it, you can see the changes from Bob. So, but how can Bob know about your changes? Maybe you put a new feature, you develop some new code, and you want him to be aware of these changes. Then you can do the so-called pull request. Yes, the next step. How to do this step here? So, how to do that? You go to the repository, and this step can be a bit confusing, right? You go to the URL of the repository that you want to target. So in this case, this is the repository that I found from Bob. I went to this URL to the repository. For instance, imagine that I went to some repository like the one I want to target. And this is not you. This is the user that has the repository. So you just go to the repository. And then you go to the option that is called fork. And I am assuming that you are logged into your GitHub account, right? So when you click on this option fork, it will start the forking process. Yes. And once this is done, you will see in your user account, in this case, imagine that you are this user, Alice. Once the forking process is done, you will get a copy of the projects from Bob. But you will see here a label that is called a fork from Bob user and the name of the project. The name of the project will be the same in this case, right? Because you fork from that project. Of the projects from Bob. But you will see here a label that is called a fork from Bob user and the name of the project. The name of the project will be the same in this case, right? Because you fork from that project. So it means that here, if you are this user and you have authenticated to this account, you can push changes to this account, but not to this Bob's first project. Yes, reflect the changes in Bob's, and then you can synchronize with your changes. Yes. But in this case, you are the user that make a commit and you want Bob to make aware of your changes. Yeah. So then you can click on this synchronize your fork. Then it will propose the so-called pull request so that Bob is aware of the changes that you made. Yeah. So you can go to this place here, create a pull request. And as you can see, because this change was very simple, then it says that the changes can be merged automatically, or otherwise, if Bob made some changes before to the same file, then you will need to resolve the conflict. Yes, and then you can start creating the pull request. Then once you get to the bottom of the page, you can create a pull request. This was very easy because no conflicts are there. And then, so this is one way to create the pull request, right? The other way to create a pull request is if you go to the Bob's URL, right? And in that, if you go to that URL, you click on pull request from the Bob's URL. So this is another way to create a pull request, and I put this to clarify. Then it will suggest what are the changes and the branches that you want to consider in the pull request of the changes that you made. Yeah? So then you type here, create pull request, and you will see something similar as in the previous case. But now you are located at the Bob's URL of the changes that you made. Yeah? So then you type here, create pull request, and you will see something similar as in the previous case. But now you are located at the Bob's URL.
Okay.
And in the case that you are logged into your GitHub account, right? So everything will proceed from your GitHub account.
Okay.
But because you're pointing to the URL from Bob, then you can push this button here.
Okay.
Click on this button and pull request. But of course, it will be from your GitHub account.
Okay.
Yeah.
Thank you.
So Bob will receive an email about these proposed modifications, and if the modifications are useful, no conflicts are there, then Bob, yes, notice here the change in the user. Bob now can merge the 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 changes that Alice proposed in the merge button. Yes. So now Bob is the person that is acting on the repository. So, okay, this is a way to interact with the users that you don't know, right? And you don't have permissions to write on the repositories. So it's another feature. I will go to this very fast. So in GitHub, you have an option called issues. So this is here. And this is useful, for instance, if you find that the repository from other people have some issues, yeah, as the number suggests. So you can go to this place here, and you can write, well, I found that this version of the code is producing these errors and so on. And then you can place an issue on the repository of others, or even on your own repository. You can place some issues if you find issues with the code or the working repository, anything that you want to target. Yes, and then you can submit the issues and make the people aware of this issue in the code, right? So for that, you will get a number for the issues. Yes, for instance, here I have some issues open, and this will be assigned with a number. In this case, is number 2. So this is the title of the issue, and you can have also the description. So the good point of this is that in your commit messages, you can refer to these numbers by typing this symbol here, the dash and the number of the issue. And when you put the commit and you push it on the GitHub, then this label will be rendered so that when the people click on that, then they will point to that issue. Yes, possible. Yeah. So yes, the last one is some recommendations which are general. Yes, especially when working with several people, there could be some convention. Yes, with your colleagues on how to work. So we have seen the network. Yes, Some people like to work in a straightforward network without so many branches. Other people like branches, and then they merge at some point. So it depends on how your team or your colleagues work, or the people where you are collaborating. So it's useful, or it's always essential to communicate to see what is a common workflow. We have seen some commands. One was mentioned today, git rebase, and they change the history, right? And it's recommended to use that on your local repository and not on public repository, because this network that you saw can be screwed up, I would say. Yeah. So if you publish them on public branches, that would be really weird for your colleagues. And you see that we created a pull request to make your colleagues aware of the changes in your local repository. So sometimes there are some proposed changes, but you don't know the person, you don't know the feature, and you don't accept the pull request right away. Instead, you can get the changes, look at the changes. For instance, here in this button, you can go to the pull request, analyze the files, see how the files are changed, and so on. And after that, you test the code and see if everything works fine, and then accept that, but don't accept it right away. So if there are any further questions on this part,